Welcome, this is a demonstration of my projectile motion function. So what I've set up is a for loop that steps the variable k from 20 to 45 in increments of 5. And the input variable that k stands for in this case is theta, or the initial angle of launch. And my projectile motion incorporates three inputs. First, the initial x position. Secondly, it inputs the initial velocity. And finally, it inputs the angle. So if I execute this loop, it will calculate horizontal range, max height, and the x location of the max height for each iteration, and then it will also graph all of them. So this is a graph of all of the different projectile motions given the exact same initial position and velocity. And so one of the things that projectile motion, the physics of projectile motion tells us is that a 45-degree angle is the optimum for horizontal range. And that's the last graph, the last curve that was generated on this map. And so you can see smaller angles. So if we look here, the last one that was graphed has a horizontal range of 10.19, and if we go up here, the horizontal range is smaller, and you can see that difference. And then the horizontal range starts to decrease even faster. And the same can be said for the other properties of the graph, such as the maximum height. The maximum height also decreases, and the location of the maximum height is increasing. Here we see the peak of the parabola at 5, and at a much lower theta, it's maybe at 3.2. So that is a demonstration using a for loop, and this here is the code for my function, and it shows what I went about in order to make this function. And this is the help file that comes along with the function, showing briefly what the inputs stand for, the outputs of the function. Mine's pretty bare bones. It's basically steps time through at small increments to a very high value. X is a function, and y is a function, and then they are graphed together with a few changes to the graph properties. So I hope this was helpful, and thank you.